Hi everyone, today I would like to talk about the Docker. Since it was not a conference paper, it was a journal, and I fortunately found some slides on the internet by this guy related to this paper. So I would especially like to thank this guy because he made my life a bit easier. However, I made significant changes in the slide to explain it more effectively. So let's start with the history of a Docker. So Docker was initially started in early 2013. After a couple of months, the first version of Docker was released, which was March 25, 2013. The Docker was a .cloud project which was intended for the platform as a service. However, due to the massive popularity of the Docker, it soon transformed into Linux Foundation, which is called Docker NC, in a couple of months, like March 25 to October 2019. It was like maybe 7 months gap, and it got a significant popularity. By the time when this paper was written, the Docker had this much of GitHub stars, around 18.6 kilo stars. And likewise, it had like 3.8 kilo of forks and 740 contributor, which means that even at that time, it was very popular. I wanted to grab some recent information, but since the Docker has moved to an official website and now everything is maintained there, so I couldn't get the recent information from the GitHub. So why do we use a Docker? Let's suppose you are a developer, you write a code and you test it on your machine, it works perfectly fine. But when you give your code to some other person and that guy is running the code on their machine, then they have trouble with it. It has a dependency hell. And the paper, this is called dependency hell because this code may require some version difference, like you are not using the particular version, the platform difference, the operating system difference. So all these kind of dependencies, they have called it dependency hell. And when you are trying to install those dependency, it would waste a lot of your time. Now, let's first discuss what a Docker is and how it could resolve this problem. Docker is an open platform for developers and system administrator to build, shape, run distributed applications. This distributed applications means one guy wrote a code on his computer and he simply give that computer code to some other guy. So the computers are distributed. One person can work on some other place and they can just simply give you the code and you can come and run in your own PC and it should be able to work. So it's like open platform for developers. It is supported by 64-bit Linux distributor and with above this kernel. So if you're using below this kernel version, then it might not be supported. But however, we are using the latest kernel nowadays with the latest Linux distribution, so it should be surely working. And it is even now supported by the Windows operating system. Furthermore, it is also supported by several cloud platforms, including Amazon EC2, Google, Computer Engine, and Rackspace. Now let's come back to that problem. Now we have a Docker. Once we have the Docker, it will resolve this dependency hell problem. And the code which was working on this guy computer, it also working on her computer. So Docker solves the following problems, namely conflicting dependencies, which means that if you're running one website, for example, on PHP 4.3 and another website on PHP 5.5, there should be no problem if you run each version of PHP in a separate Docker container. Missing dependencies means installing application in a new environment in a snapshot with Docker because all dependencies are packaged along with the application and the containers. And finally, platform dependencies means moving from one distro to another is no longer a problem. If both system runs Docker, the same container will execute without issue. So here are the features of the Docker. It is lightweight, it is portable, and it is self-sufficient. Lightweight means it has minimal overhead, it is based on Linux containers, and it uses layered file system to save space, and it uses a curve file system. Copy and write or curve file system actually efficiently implement a duplicate or copy operation to track changes. For the portability, it can run on any Linux system that supports Linux containers today. And point 7 release includes support for these open source software products, which are Red Hat and Fedora family. They are companies which provide various free and open source products. And it is even supported by the Raspberry Pi. You may probably know this device. It's just a device which you can use for various purpose in your experiments. So in this paper, they say in future plan, maybe they have already done it by now, but in future plans, they support other containers. So this is the open source version of Google Container. And it would also possibly support for other operating system like Solaris or OS X. A Docker container contains everything it needs to run, such as libraries, framework, application code, so everything is packaged all together. Now, what is the main challenge? The main challenge is there are multiplicity of stacks, which means that there are multiplicity of services and application. For example, a stack of user database, queues, web front ends. So all these stacks are there. And the question is, do they interact appropriately? And the other challenge is there is also diversity of hardware environment, such as development virtual machine or your own laptop, etc. Now, when I have something here, can I smoothly migrate that stuff to somewhere here or somewhere here? To elaborate this channel in more detail, let us see this slide. You can see that here are the multiplicity of services and application, and here are diverse hardware environments. So for each machine, there is a dependency hell. For instance, if you want to use the static website, you have to install this one. Then you would, for this one, you would need this one, then this one, then this one, and all of these you have to install. But if you want to transport all this stuff from here to here, it will be a great problem. And you need to reinstall all this stuff. So to interact all the diverse hardware environments with all the application and services, you see enormous amount of question marks here. To explain it in more detail, let's take an example of cargo transport. For instance, you have multiplicity of goods. You have a box here, a car here, some lot of seeds here, and also drums, etc. And then you have also different conveyor services. So you have truck, you have train, you have ships, etc. If you want to carry each stuff separately on different devices, it's very difficult. It's like not portable way, and also you have to put them very carefully, and it's like it will be a big mess. And it's not so easy if you are transporting for some distance on this guy, and then you want to move it to the train. Then from moving all the stuff from truck to the train will be so difficult. So again, if you see it here, for the train, if you are arranging this stuff here, then arranging this stuff here, you need a separate arrangement for all of them. And then if you want to move it from one to the other place, it would be very difficult. Two things are very clear here. One, arrangement of goods, and the other, moving the goods from one conveyor to the other one. So how to resolve this issue? It could be effectively resolved if we have a big container. And then we put all the stuff inside the big container, and then we put the big container on any of the conveyor service. So we can put the container here on the truck, and that can also be moved on this guy and also on this one, and then it could also be transported over the train and also over the ship. So it's so easy. You can easily move one thing from one place to the other. To mimic the shipping story, the Docker does the same thing with all kind of application and services. So they put everything in a container, and then that container can be transported from one device to the other device without causing any problem. Now, I hope it is pretty clear. Every device can have this simple container. It is a lightweight container, and it can be easily migrated from one place to the other. It can be created, it can be stopped, it can be start. So a lot of things can be done with this container, and you can easily move it from one place to the other, and all hardware are supporting. Now the question is why it works. There is a DevOps concept. DevOps composed of two different words, dev for developer and ops for the operations. So developer take care for everything that is inside the container. For example, what code is inside there, what are the libraries inside there, what packages are inside there, his application, his data, etc. So everything that is needed for code to properly run, it is inside this container. However, the operation guy, they look the container from the outside. They are only worried about how to logging, how to remote access this container, how to monitor this container, how to do the network configuring. In addition, all the containers, they can be stopped, start, copy, attach, migrate, etc. This kind of stuff can happen with the container by the operation guys. Now let me explain the Docker architecture. Docker architecture is composed of three parts: the user or the client, which is using the Docker, the host, which is the Docker container, and the registry, which is the cloud from where you can retrieve some stuffs if they are not available here. So first of all, the client is interfaced with the host using the CLI or command line interface. The client can send some commands, and then the Docker host is in daemon mode. Daemon mode means that it is monitoring the input consistently. So if any input is coming, it is reacting to it. Initially, when you want to create a container, for that you need an image or a template. So for template, first you run your code, and that code contains everything that you need. And if something is not here, you can pull it from the registry or from the cloud, and then you run this docker build command, and this image is built. This image will act as a template, and once you run this image, you can make it as a container. It is possible to create multiple containers from one image, and also to copy one image from the other image, to alter this image, and also to stop the container, start the container. So this container is your executable body. Whenever you need, you just are interfacing with this container, and it has all the dependencies and all the code that was written by the client. Assume that you don't use a Docker, then it looks very random. Like you would have a lot of dependencies as like this picture, and you cannot even easily control the flow of your code. So when you use the containers, it will look very systematic. You can easily start the container, you can stop the container, and you can access the container very easily and efficiently. Now, I believe that this story is very clear. How does a Docker works? You can build the Docker image first, then you create the containers from those images, and finally you can share the images via a Docker Hub or your own registry. Now, a fundamental question is, what is the difference between virtual machine and a container? If we take example of virtual machine can also do this kind of stuff. For example, you make a virtual machine, there you install all the kind of your applications which you need for running your code, and you run your code. And then whenever you want to shift your code to the other computer, you can move your whole virtual machine to the other computer, and it should be able to work. The main problem and drawback is the machine has a guest operating system, which means that virtual machine itself is an operating system within operating system. You're using your Windows or Linux. Inside the Linux or Windows, you are using another operating system, which is very heavy. It has a lot of weight, and also it needs a lot of resources from your computer. In contrast, the containers, it doesn't have guest operating system. Your application are running on the top of the Docker engines, and they are simply supported by your host operating system. So it is very lightweight, and they can be easily migrated from one device to the other device. The Docker container cycle is explained here. So once you want to create a Docker, you have to first create an image, and once you created the image, you can run it and build a container. You can furthermore do the reproduction, which means that you can commit a container to a new image, and you can run a new container from an image. Your container can also go to the sleep mode by killing the running container, and you can again waking it up by just starting or stopping the container. If you don't want a container to be used anymore, you can simply delete it, and that means the death of the container. Extinction means that you just delete everything related to the container, which means that you delete the image of that container. And here let's talk about the Docker file system. It looks like a makefile system, which has shell scripts with some keywords, and it starts from a base image. It means like some things like hello world program. You have some hello world template there, and you started there, and then you can develop your own code with a new Docker image. And its code is imperative, not declarative. So a declarative programming does not specify its control flow explicitly. However, it defines what the program does. In contrast, the imperative programming defines how the program should do something by explicitly specifying each instruction step by step. And finally, the Docker run is used to run a Docker file. Here you can see the list of Docker CLI commands. CLI stands for command line interface. If you carefully look at it, all the commands are same as Linux based. Since Docker itself is a Linux based, so all the command it is using are from Linux, like attach, build, commit, image, kill. For example, kill a running program, ps, list containers, rm, remove something. So all these things are used by the Linux, so they are pretty similar. In this slide, I would like to wrap up my presentation. Docker is rapidly expanding ecosystem and easy to build, run, and share. It has better performance virtual machines, and it has layer file system gives us Git-like control of image, and it reduces the complexity of the system builds. Now let me answer to the three questions. Why the problem is important? I would just answer it with one word: dependency hell. Dependency hell means that if you write the code on one computer and you take it to the other computer, it doesn't work. Then you need something universal on which you put your code and it should work everywhere. What is the novelty? The novelty is it is a lightweight system compared to the virtual machine, for example, and it provides easy interface for DevOps, which means developers and operations. And regarding the question, what is my impression? So here, first, I just take a look at the popularity of Docker over time in the Google Trends. And if you see, this is the interest over time. Since the Docker was started from 2013, now it is 2022. And you can see the growth is so kind of exponential. You can see it is just growing. There are little dips, but still it is growing. Even in South Korea, if we look at here, it has been used a lot in Seoul, like it is interest by subgroup. So I just consider the South Korea region. So it is used in Seoul, in Daejeon, and also in Incheon. So in a lot of places, it is still currently in use. And it has been adopted by a lot of giants. I know a couple of them. For example, I know Adobe, Netflix, PayPal. So they are big giants and they have adopted the Dockers. So my impression is it is a very good work and still in use. So that is all from me. Now I'll take your questions.